all of my Math 8, 8th grade math students. Today we are going to be taking just a few minutes to do a review of our Unit 8 practice test. So you should have by now taken the Unit 8 practice test on Edulastic. You should have gotten your score, seen how you did, been able to compare your answers to the actual answers. And at this point, I'm going to go problem by problem so that you can get an explanation of every single thing you need to know from Unit 8. Now, for this review, you can feel free to fast forward to any particular part of this video that you feel like you need help with. So if you understood numbers 1 and 2, but you needed help on number 3, feel free to skip ahead, rewind, pause, do whatever you need to do in order to help you review. And by the end of this video, your goal should be, I know how to get 100% on the Unit 8 assessment. Okay, so here we go. We're going to start off with number 1. An observer is standing 20 feet from a tree with a hanging birdhouse. She's looking at the birdhouse. How far from the ground is the birdhouse? So that's x. We're trying to figure out what x equals. And what do you know? This situation creates a right triangle. And when you have a right triangle, we have learned in Unit 8 that a squared plus b squared equals c squared. This is the Pythagorean theorem, and it's one of the most important things in Unit 8. In fact, this is one of the most important things that you're going to learn this year in math. This is one of the big 8th grade math concepts, a squared plus b squared equals c squared, which is just an abbreviation of the Pythagorean theorem, which says that for any triangle that happens to be a right triangle, this only works if there's a right angle there, the length of one of the legs squared plus the length of another leg squared equals the length of that third side, which we call the hypotenuse squared. So for this problem, we're just going to put in the things that we know and use them to solve for the thing that we don't know. So let's just go piece by piece. 20. Is that a leg or a hypotenuse? That's a leg. So I'm going to put a 20 here. X is also a leg, right? The legs are the two that form the right angle. So that is going to be an x squared. And then the hypotenuse is 25, so I'm going to put a 25 squared. Now I have set up my equation, and now I just have to solve this equation. So I'm going to go ahead and use my calculator to help me out here. 20 squared is 400. I don't know what x equals. 25 squared is 625. So now, in order to solve for x, I'm going to have to do two different things. I'm going to have to get x squared by itself by subtracting 400 from each side. And then when I have x squared by itself, I'm going to have to do a square root to solve for x. But first, what's 625 minus 400? 225. I didn't even need my calculator for that one. And so whatever x is, it will be whatever the square root of 225 is. In other words, if this number squared makes 225, I have to unsquare the 225 to figure out what that number is. And that's where, again, our calculator is going to be very helpful. And hopefully you know how to do a square root on your calculator. This is how I do it on mine. Hey, look at that. 15 feet is the height of the birdhouse above the ground. Okay, so far so good. 15 seems reasonable for this situation, and it's always nice when this number has a nice clean square root because it's a rational number. Although you can imagine sometimes that number might come out irrational and we might have to do this. We didn't have to round because that came out clean, but sometimes we might have to round. So if you do, just look and read to see what the instructions tell you about rounding, and your calculator can really do the rest of the work for you. Okay, so hopefully that made sense. By the way, a quick little footnote on this one. Notice this was 15, which is 3 times 5. This is 20, which is 4 times 5. This is 25, which is 5 times 5. This is really just Pythagoras' good old 3, 4, 5 right triangle, just multiplied 5 times as big. Oh, that's kind of cute. All right, Kenneth. Kenneth wants to wrap a collapsible fishing rod. Okay, interesting. In the box, and the fishing rod is going to kind of have to go diagonally to fit inside of this box, right? How long is that diagonal? Well, this might look like it's a problem about a box, and it might look like it's a problem about a rectangular prism, but really it's a right triangle problem. So you can ignore the rest of the box and really just look at this right triangle. Where's the right angle? Right here. So x, 18, and 10, I'm going to do my A, B, and C, and I'm going to figure out which pieces go in which slots. So A squared, B squared, C squared, again, is what we're going to use. Leg and leg. The two legs are 18 and 10. So 18 squared plus 10 squared equals the hypotenuse, which we do not know, and that's what we're going to solve for here. Again, I'm going to use my calculator. So what the heck is 18 squared? 18 times 18 is 324. Plus 10 squared, I can do that in my head. That's 10 times 10. And for this one, unlike up here where I had to subtract and then unsquare, this I'm just going to add and then unsquare. So what does that come out to? Well, let's find out. The square root of 424, it's irrational. So what would I say about x? I would say x is about 20 point, round to the nearest what? 10th. So I'm going to say it's 20.5, but that 9 would bump that 5 up to a 6. So x is about 20.6 inches, and that's what I would type in to my Edulastic on this problem. Maybe you got the right idea here, and you just didn't round correctly, and maybe that's why it was marked incorrectly. And now you can kind of see, oh, I just got to watch the directions, round to the nearest 10th, and that will help you make sure that you can get these problems right. So again, Pythagorean theorem is probably the most important thing that we have learned in quite a while in math. A squared plus B squared equals C squared. Leg squared plus leg squared equals hypotenuse squared. Thank you, Pythagoras and all the Pythagoreans, for enlightening us with that amazing fact about right triangles. Next up, we got question number 3. Find the distance. And we've got a couple of different points. So I guess what I could do, if I wanted to, I could draw a graph. I could plot these 2 points. Oh boy, those are kind of icky points, right? I could do it though. Let's just kind of estimate. So 4.25 comma 5.5. I'll just estimate it, right? There's point A. And then 3.512, 3.50. So I've got that distance. And again, this is just a Pythagorean theorem problem, isn't it? Because the distance between any 2 points kind of makes a right triangle. Okay, so what's the height of this triangle? Well, wasn't this 5.5? Right? Because it went from 0 to 5.5. And what's the width of this triangle? What's the base of this triangle? Well, it's from 3.5, right? From 3.5 to 4.25. So how far did that go? Actually, you would probably do it this way, right? 3.5 subtracted from 4.25, and I believe what you get here is 0.75, right? So I could just do a squared, b squared, c squared with those two numbers in order to find this distance. I'll put a d for distance. You could have put a c, like c squared, or an x. So 0.75 squared plus 5.5 squared is going to equal d squared. And I definitely want my calculator for this. So 0.75 squared to 5 plus 5.5 squared, which is 30.25. That's going to equal d squared. I'm going to add these together, so it's going to be whatever the square root of 30.8125 is, that's my distance. So I'm going to do the square root. Whoops, what did I do wrong? Oh. There we go. So that distance, how far apart are these, is about, well, round to the nearest tenth, 5.6, because that would round that up to 5.6, and that is what we would put here, 5.6. Now, you did not have to do this problem this way. You did not have to draw a picture. You might prefer to do this problem with something called the distance formula. The distance formula is an interesting formula. It says the distance between any 2 points is the square root of the second x minus the first x squared plus the second y minus the first y squared. And so you could have just plugged the right numbers into the right spots on this problem. So the second x minus the first x, the second y minus the first y, and you could have done it this way. So you would have done 3.5 minus 4.25. Wait, that's kind of like this, but it would be negative. Oh. And when you square a negative, it's going to turn out positive, isn't it? Interesting. Plus y2 minus y1, that's 0 minus 5.5. So that'd be negative 5.5. But again, the negative doesn't really matter because when you square it, a negative times a negative is going to become, this is really the same thing as the Pythagorean theorem, isn't it? With this formula, and you don't have to draw a picture if you don't want to, or if you like drawing a picture, you can draw a picture. Or what I'll show you on the next problem is you can kind of do a mixture of both by doing this. If I just write -5, -2, and I'm moving on to question 4 now, by the way. So I put point C and point D, I lined them up. And since I'm subtracting with this formula, because I'm finding how far apart these points are, right? How far apart are they? That's why it's subtraction. Then really all I need to do here is do a bunch of subtraction. What's -2 minus -5? -2, that's like plus 5. So that's 3, right? So that would be like this part of the formula. So I'm going to square it. And then 4 minus -2. That minus negative becomes a plus positive. So 4 minus -2 is 6, right? And now I just have to do this. So 3 times 3 is 9. 6 times 6 is 36. And I can add those together. That's the square root of 45. And whatever the square root of 45 is, that's my distance. Now on this one, it didn't say round to the nearest tenth, but it should have. So on this one, even though the directions probably should have told us to do that, we'll do it ourselves. Because that's irrational, and we have to round, but the distance is about 6.7 units. Okay, so I showed you basically on question 3 and question 4 3 different ways that you could do a distance problem between 2 points. I don't care, as long as you're comfortable with it, you can go draw it out and use the Pythagorean theorem. You can use the distance formula, or you can kind of use this shorthand version of the distance formula if you want to. The one thing you just want to pay close attention to is be careful with your pluses and your minuses, your positives and your negatives. Okie doke? All right, now question number 5. Totally different problem. This one is not about here. There's no right angles here, but there are some angles here. And this is what we call parallel lines cut by a transversal. When two lines are parallel and they're cut by a transversal, we now have 8 different angles. We have 4 acute angles and we have 4 obtuse angles. And the beautiful thing about a scenario like this is all obtuse angles are what? Equal or congruent. And we could also say the same thing about the acute angles. They're equal or congruent. So we need to look at this angle right here and this angle right here, and we need to decide, are they acute or obtuse? Well, this one is acute, but this one is obtuse. So are they equal to each other? Are they? No, because this one's less than 90 and this one's more than 90. They're not equal to each other. Although, okay, if this had been just in one of these other spots, then we would set it up this way and solve that equation, and that would tell us how to know what x equals. But since these aren't equal, we can't do it that way. So if they're not equal, what are they? We'll look at any pair of acute and obtuse, or this acute and that obtuse, or this acute and that obtuse, or this acute and that obtuse. What do you get when you put them together? In this situation, when you put together any pair of acute and obtuse, you get how many degrees? It's a straight line. It's 180 degrees. And that means that this acute and that obtuse, when you put them together, should add up to 180 degrees. And that, for this problem, is the equation that you are going to solve in order to get your solution. Be careful. And one obtuse, and you do it this way. 1 plus the other equals 180. Or if the diagram that you're given is both acute angles, then you would have done it this way, right? You would have set them equal to each other. Or if they were both obtuse angles, you would say they're equal and then solve that. So you have to be careful and look at the diagram before you set up your equation. Once you've set up your equation, if I've got an x and 2 more x's, if I've got a xylophone and 2 more xylophones, I've got 3 xylophones. Plus 35 plus 1 is plus 36. All right, I'm starting to get an equation that's looking pretty solvable, so I'll take away 36 from both sides. Now I've got 3x equals, let's see, 144, and so I'm going to divide 144 by 3. And my answer is going to be 48 degrees. X equals 48 degrees. I don't know if you had to put the little degree symbol in there in Edulastic or not. Probably not. Okay, so now, wait a second. X isn't 48 degrees. X is 48, so how many degrees is this? It's not asking you to do this, but follow me for a second. If X is 48, 48 and 35 is 70, 83 degrees. Does that seem reasonable for that? Yeah. And if x is 48, 2 48s is 96 plus 1 is 97. That's an obtuse angle. That's an acute angle. So that shows me you did this correctly. Plug that answer back in and see if it makes the acute angles acute and the obtuse angles obtuse, and that should give you a pretty good clue about whether you are on the right track or not. Okay, 5 questions down. A few more to go. Question number 6. Find the value of x. Okay, this has to do with what we call the triangle sum theorem. And I bet you might have known this before 8th grade. The triangle sum theorem says that the 3 angles of a triangle always add up to how many degrees? 180. Boom. There's my equation. I just have to solve it, right? This plus this plus this equals 180. So now 65 plus 75 is 140. Take that away from 180. Hopefully I didn't confuse you by doing that kind of combined into one step. And x must equal 20. How do we know if that's true? Okay, we know that x equals 20, so this would be 40 degrees because 2 20s is 40, and just add that up. Does it make 180? Yep, it does, right? 65 plus 75 is 140 plus 40 is 180. So this is the 180 rule. Question number 7 is also going to use the 180 rule, but when we start to set this up, I'm going to say this angle plus this angle plus, plus what equals 180? I don't know this. It doesn't give me that angle. It's not 62 because that's obtuse, right? The 62 is outside of the triangle. But wait, don't these two together form 180? Yep, they are supplementary. So to find that angle, all I have to do is 180 minus 62, and that will tell me what that angle is right there. So that's going to be 118. So 118 is what I'm going to put right there. Now I've got an equation, and all I got to do is solve it. X plus x is 2x. 14 plus 118, let's see, it's 122, 132. Now you just got to solve that equation. So I'm guessing if you missed this problem, you might have put a 62 right here instead of a 118. Hopefully you can see why you needed to use the 62, right, to help you find the 118, to help you find x. And I'll go ahead and finish this. But 48, I think. Let's see, 130, yeah. Then I'm going to divide by 2, divide by 2. I get x equals 24 for my solution here. And again, just to make sure that I did this right, that would mean that this is 24 degrees over here. This is 24 plus 14, so that'd be 38. That's acute, seems correct. This we decided was 118. Do those 3 add up to 180 like they're supposed to? They do. So that's how we know that we got this correct. All right. Question number 8 is a conceptual problem that you really have to read carefully. What is true about the sum of the measures, of a triangle? Well, we know 80, right? So something plus something plus something equals 180, right? The sum of the angles of a triangle. But now it's saying, what is true about the sum of the measures of the 2 non-right angles in a right triangle? What's a right triangle? A right triangle is any triangle that has a 90-degree angle right there. Oh, that means one of those 3 is 90, right? So what is true about the sum of the 2 non-right angles? In other words, what's true of the sum of the 2 non-right angles? Oh, well, if this is 90, what's left over? 90, right? 90 and 90 make 180, so the sum of those 2 is 90. Now, we don't know what that might be. It might be 45 and 45 make 90. It might be 10 degrees and 80 degrees make 90. It might be 30 and 60 make 90. But whatever happens, these 2 angles in a right triangle always have to add up to 90. So this was just kind of testing you to see if you could kind of picture this or sketch it out in order to answer the word problem. Alrighty. Couple more problems. Let's see what we got here. Get my pages straight. What is the perimeter of the triangle? Okay, so the perimeter of the triangle here. The perimeter of the triangle. What's a perimeter? The perimeter is this plus this plus this. So the perimeter is x plus 3 plus 4. But we can't put that here. We need to figure out what that number is. So in order to figure out what that number is, I'm going to do a squared plus b squared equals c squared. Although, I think you might notice that when the two legs are 3 and 4, we've heard of this. It's a 3, 4, what? 5 right triangle, right? Isn't this 5? Remember Pythagoras and his good old 3, 4, 5 right triangle from the Egyptian rope and all that kind of good stuff. So maybe you didn't know that. Could we have solved this? Yeah, that's 9. That's 16 equals x squared. So if you didn't remember that, you'd have gotten 25, and then you'd have square rooted it. And so somehow we would have known that that's 5. So if this is a 5 plus 3 plus 4, we've got 8 plus 4, which is the perimeter is 12. Okay, not too bad once you kind of think your way through that. Question number 10 is kind of similar to what we had a few problems ago when we had number 5, two parallel lines cut by a transversal. We've got a bunch of different angles here, some of them acute, some of them obtuse. Is x acute or obtuse? X is obtuse. Do you see any other obtuse angles formed here? By the way, ignore that. Isn't that just kind of a distraction? Isn't that just kind of a trap trying to get you off track? Yeah. So we can ignore that. What matches that x? Oh, wait. X is 118 because the obtuse angles have to match. Easy. Easy. Okay, so we like these kind of problems with parallel lines and transversals. Obtuse angles will be equal, and if you somehow had only the 62 here and it didn't tell you that, you could have still figured out that that was 118 by using the 180 rule, because those are supplementary. Okay, good. 11, which pair of angles is congruent? Okay, same idea. So we're going to look at angle 1 and angle 8. Angle 1 is obtuse. Angle 8 is acute. They cannot be congruent if one's bigger than 90 and one's smaller than 90. 3 and 5. 3 is obtuse. 5 is obtuse. Yes, those are congruent. But let's just check the rest just to make sure. This might be one of those problems that has multiple answers. Part C, 4 and 7. 4 is acute. 7 is obtuse. Acute, obtuse, cannot be congruent. 2 and 5. Acute, obtuse. Nope, B is the only answer. And it's as simple as just looking and seeing which ones are acute and which ones are obtuse. Easy as that. Okay, Crystal uses a stick. Draw, okay, keywords, right triangle. So, draw a right triangle. You can draw it like that. You can draw it tall and skinny, whatever. It doesn't matter. Just draw a triangle that has a right angle in it. And then just start reading and labeling. The hypotenuse is 24. One of the legs is 12. I could put the 12 here. I could put the 12 here. Doesn't really matter. What's the length of the third side? This is really just an a squared, b squared, c squared problem. So I'm going to do 12 squared plus x squared. Those are my legs. Equals the hypotenuse squared, right? 24. And again, just calculator. So make sure that you have a calculator handy when you're doing this. 12 times 12, I know that one. That's 144. 24 times 24, I don't know that one off the top of my head. 576. So I am going to subtract 144. Hopefully you understand why I'm subtracting at this point, right? Because I've got to get x squared by itself. So I've got to get rid of this. So 576 minus 144 is 432. What am I going to do to the 432? I'm going to square root it, and x is going to be whatever the square root of 432 is. And if it comes out irrational, I'm going to round to the nearest tenth. So square root 432 is about 20.8. About 20.8 inches. Again, if you're missing some of these problems, it might be because you were close, but you just didn't quite round according to the directions. So be careful with that, and you should be just fine. We're getting close to the end here. 13 and 14. A triangle has side lengths of 10, 24, 26. Is it a right triangle? Well, if it is a right triangle, then this would be the hypotenuse, because the hypotenuse is always the longest side. That would mean that these are the legs. And if it is a right triangle, then the leg squared plus the other leg squared should equal the hypotenuse squared. So if this is a right triangle, then this should work. 10 times 10 is 100. We said in the last problem that 24 times 24 is 576. Again, you could put that into your calculator if you need to. And so if 26 times 26 does not come out to, right, 676, then this is not a right triangle. So 26 times 26, moment of truth, it does come out to 676. So is this a right triangle? Yes, it is. So if this came out to this, you would click yes. If this did not come out to this, then you would check the no box. Simple as that. Simple as that. No problem. Okay, just more Pythagorean theorem, a squared, b squared, c squared, and finally, Pythagorean theorem works in Colorado too. So the shape of Colorado is almost rectangle. It's not exactly a rectangle, but it's pretty close, so we could use the Pythagorean theorem to at least estimate that this is kind of like a right triangle right here. And we know the hypotenuse of that right triangle. So really, Colorado doesn't have much to do with this problem. This is really just another right triangle problem in disguise. How am I going to set this up? I got to go leg squared, hypotenuse squared. So x is a leg. 280 is a leg. 450 is the hypotenuse. Man, these numbers are going to get big. So 280 squared, I definitely don't have that memorized, is 78,400. 450 squared is 202,500. And because this is a leg, I've got to subtract this from both sides so that I can get x squared by itself. So 202 minus 78400 is 124,100, 124,100. I'm going to unsquare that number to get x. I have no idea if that is going to come out to a rational or an irrational number. Let's find out. 124, 100. Irrational. Colorado. Come on. Irrational dimensions to your state. What a disgrace. Just kidding. Okay, this time it says round your answer to the nearest whole number. So how many miles wide is Colorado? We're going to say 352 and leave it at that because the 0.2 would round down. So find the missing side, 352 miles. Does that look reasonable on this map? Seems reasonable to me. Seems reasonable to me. Then find the estimated land perimeter. So once you know the dimensions, we could find the area of the state of Colorado. We could find the perimeter of the state of Colorado. We could do all kinds of things here. So this follow-up question is basically going to say, now that you know this, what's the perimeter? Well, the perimeter is this plus this plus this plus this, isn't it? So it's 352 plus 280 plus another 352 plus another 280. And we'll let our calculator help us out on that one. 352 plus 280 plus 352 plus 280. Hopefully I didn't hit any wrong buttons. 1264. So if you drove, why did I write 5? So if you drove around the edge of Colorado, you would drive over 1,200 miles. That'd be a long trip. And you definitely have to drive through some mountains. But that would be your end result. So hopefully that all made sense. Again, you didn't have to listen to all of this, but hopefully there was something in there that helped you out. Thank you for taking the time to tune in. I think if you watched and listened, you probably learned. And if you have any follow-up questions, anything that still didn't quite make sense, just let me know, and I'm happy to help. Thanks for watching. Thanks for listening. I will see you next time.